Having us, good morning, and thank you for having us here in person and virtually. My name is Lakshman. I'm a partner manager at Intel. And here with me today is my colleague, Emmanuel, who's an AI specialist. And we'll be talking about our efforts at Intel to scale AI in enterprise. So before we start, I just want to talk about what we've done with Databricks, and then I hand it over to Emmanuel. We at Intel are very focused on optimizing workloads on the cloud. And one of the workloads that we have optimizing is the Databricks runtime and the Photon engine. So there we have been collaborating with Databricks on that. And then the other area we've been looking at is incorporating the optimized Intel software libraries, AI libraries within Databricks. I will pass the mic off to Emmanuel, who's going to spend a lot of time covering just our broad portfolio of AI assets at Intel.
So hi everyone. Thank you for joining us today. So for me, the goal is really just to give you an overview of what we do at Intel in AI. And so I will start by explaining the accelerators that we use in our hardware to accelerate AI. And I will then discuss the software and the tools that we have, again, to use AI at Intel. So first, I just want to present to you the machine learning pipeline that we have typically. So we have data, we have model, we deploy those model. And I just want to show you that the majority of data processing today is done on CPU. You also deploy 70% of AI models, again, is on CPU. And most of the traditional machine learning, again, is done on CPU. And for training deep learning models, there is a mix of CPU and GPU. Most of it is on GPU. But we can still have CPU for a small section of them. So this pipeline, I just want to show you that most of it, again, is done on CPU. So why Intel is here at an AI conference is because of this pipeline. Most of the AI that is being run today is run on CPU. And I just want to here explain why CPU, we made an acceleration on CPU. So as you can see here, the mathematical operation that is being the most used on CPU is matrix multiplication. And this is what at Intel on our CPU we want to accelerate. So you can see on the right there's traditional convolutional neural network. And within, for example, the convolution and the pooling layer, there's a lot of matrix multiplication that happens. And this is really what we, on our CPU, wants to accelerate the most. So there's 3 generations of accelerators that we integrated into our CPU. You can see that the first one was introduced by Cascade Lake. And I will explain what it is. But then we also had Cooper Lake, who introduced the 2nd generation of accelerators. And the last one will come with Sapphire Rapids, which is not out there yet. But this is the latest CPU that we will provide. And the most sophisticated acceleration will be with Sapphire Rapids. So first of all, again, Cascade Lake, we introduced AVX 512 VNNI. This is the first AI accelerators that we introduced in 2019. And as you can see here, no, it doesn't show, but yeah, so that's the matrix multiplication. That's the mathematical operation that we want to accelerate. And Cascade Lake, what we did here is we combine 3 operations into a single one. And that provided us with enough acceleration to justify it. And the second one was introduced with Cooper Lake. So as you can see here, the first thing that we done was to create a new data type. So it's called bfloat16. B for brain because it was in partnership with Google Brain. So we created this new data type. As you can see, we just reduced the Mentisa to a smaller number because we realized that with AI, we don't need that much precision. So in CPU, with Cooper Lake, we convert float 32 into B float 16, and we do this dot product that is one of the operation within matrix multiplication. And the third acceleration will come with Sapphire Rapids. It's not out there yet, but it will come soon. So this is called AMX. This will be the most sophisticated accelerator that we will provide. It comes with 12 new instructions within the CPU. And AMX is a standalone extension with its own storage and its own operations. So again, this is not out there yet, but it will be soon. And I just want to say that all the accelerations that I presented to you can be leveraged automatically. So the end user don't have to do anything other than doing their regular AI. So you code for you build your model, for example, in TensorFlow. And TensorFlow, under the hood, will use one API, which is one of our tools that we use to accelerate those operations. So again, you don't have to do anything. This is all automatic. So yeah. And yeah, so that was for CPU. I just want to show you that we also have GPUs coming. Arctic Sound will be used for, it's a multi-purpose GPU. In terms of AI, you can use it for inference. It's not the GPU that we will recommend for training, but if you want to do inferencing, Arctic Sound will be available. And you can do other workloads with this one. So for example, there's VDI, there's media analytics that you can do. There's also cloud gaming that you can do with this GPU. But Ponte Vecchio will be another GPU that Intel will launch soon. And this one will be you will be able to do training with this one. So again, at Intel, you can do AI on CPU, but you will soon be able to do it also on GPU. And we also have Abana, which is a company that we acquired 2 years ago. The main value proposition for Abana right now is that you can train deep learning on Abana for much less money. So that's the main value proposition of Abana. And as of yesterday, we provided new benchmarks on MLPerf. And it's, I don't show it here, but we achieve a very great performance with Abana now, with the second generation of Abana. And then, yeah, so pretty much all the common deep learning models are supported with Abana. And yeah. So currently, you can use Abana on-premise through Supermicro, but you can also use it on AWS. So there's 2 ways that you can, at the moment, consume Abana. So that was it for the hardware acceleration. I will now talk about the AI softwares that we have. The first one is called OpenVINO. Again, OpenVINO is done for inferencing. So you build your model with optimized AI frameworks that Intel is providing. You can then deploy your model on any hardware that we have using OpenVINO. So it can be used for computer vision, NLP. It can be deployed on edge, or it can be, again, deployed on data center. So this is another tool another company that we acquired, I would say, 1.5 years ago. It's called SIGUP. So this is a tool that you can use to optimize the model itself. So with SIGUP, it's automatic. You can fine-tune the model itself. And since it's using Bayesian optimization in the background, under the hood, let's say, you can speed up the training of your AI model by a huge amount. So for example, PayPal reported that they were able to reduce the training time by 40%. So you can imagine all the money that customers are saving by using SIGUP. Another one is 2 Sigma, which is a big trading firm in New York. They were able to reduce the trading time by 24 days to only 3 days. So you can, again, imagine all the money that those customers were saving by using SIGUP. And the best part of SIGUP is that it's it's not free, but it's almost free. It's really cheap. So again, by using SIGUP, you can save money without investing any kind of. So this is a very popular tools that Intel is providing. I'm personally helping a lot of customers with this one. And again, it's a great value proposition for us. The other one is called Converge. It's an end-to-end MLOps platform where you can train and deploy AI models with just a few clicks. It's really simple to use. The main value proposition here is that if you're not a DevOps expert, you can use this platform, again, to do machine learning training and deployment very easily. And under the hood, it's using Kubernetes, which is very popular at the moment. So this is, again, a company that we acquired a year and a half ago. And so this is now big deal is open source projects that we created at Intel. This is used to scale up AI. So for example, you may create a model on your laptop, and then by using Big DL, you can deploy it in data centers very easily. And it's using all the optimization on CPU that I discussed previously. We have public projects with MasterCard, Burger King, Alibaba. So there's big companies that are using our tools to deploy and scale up AI in data center. And it's super easy to use. It's just, as you can see, a standalone Spark job. So it's you don't have to do a lot of maintaining to do so. And yeah, so again, Big DL is open source, so you can actually even fine-tune the code for your own use. And yeah. And the last thing that I want to say here is that at Intel, we also invest in AI. So we have a program called AI Builders, where we invest in companies and we use those companies with us, on customers. So we partner with a lot of different smaller companies, but with Intel Capital, we also make acquisition. So I just wanted to say that with Intel, we are not just a hardware company. We also provide services on AI with our partners that we make investment in. And with that being said, thank you so much for being here. It was a really great pleasure for me to be here. Yeah. Thank you.